Okay, part D. We're going to take a look at potassium dichromate, and we're going to see what happens and how we shift this equilibrium. Now, dichromate is more of an orange color, and the chromate is more of a yellow color. So we're going to start off with our first test tube. We're going to start off with about 3 milliliters of our dichromate, which is this yellow color. And we're going to add 5 drops of nitric acid. While I'm doing this, we've done a few of these now. See if you can predict what you think is going to happen. Changed color a little bit. Let's start off with a fresh batch of dichromate. Okay, so again, for comparison, here's our dichromate, and this is after we added the nitric acid. Okay. So let's put that test tube 1 back in its place. And now for test tube 2, we're going to add a similar amount, 5 drops of sodium hydroxide. Whoops, I'm sorry, we want to go to the same test tube, not a different test tube. So we take that orange test tube that we added acid to. What do you think is going to happen if we add sodium hydroxide? Okay, here we go. Change color back to our control. So it lost some of that orange, went back to yellow. Okay. So hopefully we're starting to kind of see how we're pushing equilibrium to the right or to the left. We can keep going back and forth if we want. Let's add some more nitric acid to it, right? So here's our same test tube, and adding some, we can see it changing color and turning more orange. And we'll go right back again with some more sodium hydroxide. So Le Chatelier's, we're just pushing the equilibrium to the left or to the right. Okay? So hopefully you can understand and you can explain that to somebody else. How are we pushing that equilibrium? How is that happening? Okay, that's part D.